We're going to start a new unit this week. It's called Right Triangle Trigonometry. And I feel like this one is probably the most useful of all of our units in trigonometry, because even if you're not going to be an engineer, you can still use this trigonometry for the rest of your life in helping you in construction, or if you want to do something at your house. It just comes in handy. So right triangle trig is also the same kind of trigonometry that you guys should have learned back in Algebra 1 or geometry when you talked about the trig functions. If you don't remember, that's okay, because we're going to go over all of that again. So off talking about the same things we've been doing throughout the whole unit. Whenever we define sine, cosine, and tangent, we used x, y, and r to define them. And those related to the sides of a right triangle. And that triangle was in the unit circle. And the angle of reference that we used was at the center, or at the origin of that coordinate plane. And so x was always on the x-axis, the y up and down like the y-axis, and the r was always the radius of the circle. But when we look at this triangle, if we're talking about where these letters fall in relationship to the angle, then when I look straight across from the angle, I have y. So across from y, or opposite the angle, is y. When I look at this picture, the side right beside the angle, or the side that is adjacent to the angle, is x. Now r is also adjacent to the angle, but r is the longest side, always across from the right angle, and so this side is the hypotenuse of a right triangle. So we have opposite, adjacent, and hypotenuse, which is what we can use in right triangle trig if the angle or the triangle is not placed on the unit circle. So if I look at, I know that sine is y over r. If I look over here, y is opposite, r is hypotenuse, opposite over hypotenuse. Or here it is right here. Sine is opposite over hypotenuse. Cosine is x over r, or adjacent over hypotenuse. Tangent is y over x, or opposite over adjacent. So regardless of whether or not my angle of reference, which is usually at the origin, is in the coordinate plane or not, I can use these terms even if I can't really figure out which one is x, y, or r. So in this triangle that I've got drawn here, this is my angle. So straight across becomes my opposite side. This would be my adjacent side, and the longest side, the one that's always across from the right angle, would be my hypotenuse. Now, if I were to switch that out, same triangle, exact same triangle, but this time I let this angle be the angle of reference. Then if this is the angle of reference, across from it is the opposite side. This would be the adjacent side, and the hypotenuse is still going to be the longest one across from the right angle. Okay, so keep that in mind. This one is kind of like having an X and a Y and an R, but this is not. This angle is not the one that would be at the origin on a coordinate plane. So just, try to make the adjustment to using opposite, adjacent, and hypotenuse, and it'll make this a whole lot easier. Okay, so down here, we have a triangle drawn for us. It's triangle ABC. Now you need to know, in all of the triangles that we draw, these are the angles. Angle A, angle B, and angle C. And in this picture, angle B is my right angle. The sides across from these angles are always labeled with the lowercase letter. So if this is angle A up here, then this would be lowercase a, side A. If this is angle B, then this is side B. If this is angle C, this is side C. All right, so if I use this as my angle of reference, and I'm going to use that one because it's the only one they gave me, the only one I know, then if I wanted to find this side, side C, then I could use opposite, because it's opposite the angle. And then the only other piece of information that I know is this one. I've got to have the angle and a side, or two sides. I've got to have two pieces of information in my ratio. So if I'm using this angle and this unknown, then I have to use this one. And in this angle, this would be my opposite side. This would be the hypotenuse because it's the longest or across from the right angle. And so if I'm using opposite and hypotenuse, then that would be the sine ratio. So here's how I'd write it. Sine of 25 degrees equals opposite C over hypotenuse, 14. All right. Now, once you get it set up, you're just going to use your calculator to solve. All right. I had to grab my calculator. So here we go. So when we're going to put these in the calculator, all of our angles are going to be in degrees. So when you are looking at your calculator, whether it's a handheld or if you're using something online, be sure that you check the mode and that it is in degrees. So highlight degrees, and you only have to do that once and it should be okay. All right, so what we want to do here is solve for C. So that means we need to multiply by the denominator. And so C is going to equal 14 times sine of 25. So we just type that in here. 14 sine of 25 gives us 5.917. All right. So that gave us this side. So we already know this one now. So now I'm going to go back to my picture because we want to find all of the missing parts. So if I already know this one, I'm going to mark it off like we already have it. That leaves me with side A to find because I already know side B. Well, if I'm using this angle again, and I'm using side A and side B, this would be the adjacent and the hypotenuse. This is my adjacent side and my hypotenuse. So adjacent and hypotenuse would be cosine. So I would write cosine of 25 degrees equals the adjacent side A over the hypotenuse, 14. And then I solve, multiply by 14. So A equals 14 cosine of 25. $12.688. All right, so we have side C and side A. We already knew side B, so we have all of the sides. Now, as far as the angles go, we were given that angle C was 25. We know that angle B is 90 degrees. So now we just need angle C. Well, we don't need trig for that. We just need some basic geometry. We know that in a triangle, all of the angles add up to be 180 degrees. So if I take 180 degrees and subtract 90 and 25, subtract the other two angles. So 180 minus 90 minus 25 would give me 65 degrees. So angle B is 90, angle C is 65. So in every triangle, there are going to be 6 parts, 3 sides, 3 angles. So 2 of those pieces have to be given to you or you can't do this. So 2 pieces have to be given, you're going to find the other 4. All right, I kind of skipped this up here. Let's go back and talk about this. This is just a little acronym that's supposed to help you memorize the trig ratio. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA. SOHCAHTOA. Sounds like an Indian word, but that's how we, sometimes it helps some people memorize the trig functions. All right, so we have another example here. This time, the two pieces of information that are given are two sides. That's okay. We already know our 90-degree angle as well. We have to have a 90-degree angle or this doesn't work. Only works for right triangles. So we know we got a right angle. We know we have those two sides. So let's talk about side A here. If I want to find side A, I really don't need trigonometry for that either, just some real basic geometry, because Pythagorean theorem would help me define side A. A squared plus 4.37 squared would equal 7.25 squared. Always remember that the hypotenuse goes out there by itself. So I'm going to put 7.25 squared and subtract 4.37 squared. And I get 33.4656. So A squared equals 33.4656. And of course, I need to take the square root of that. So the square root of that answer. So 5.785. All right, so there's one missing piece. Now on the angles, we already know that angle C is 90 degrees. But I don't know any of the other angles, so I can't just subtract from 180. So now I'm going to need some trig. So it doesn't matter which one you find first. I'll just do angle A first. So in relationship to angle A, the two pieces of information that I was given, this would be my adjacent side to angle A, and this is the hypotenuse, the longest side across from the right angle. So adjacent and hypotenuse, that's cosine. So cosine of angle A equals adjacent 4.37 over hypotenuse 7.25. All right, so this is very important. And if you were in class, and I would be saying it every day over and over again, if I am looking for the angle, then I'm going to use what's called the arc sine or the inverse sine, or inverse and arc cosine, or inverse and arc tangent. In this case, the arc cosine. So the inverse or arc cosine, in order to pull that up, I'm going to use cosine -1. It's going to, so second cosine. So whatever calculator you're using, look for arc cosine or cosine -1 anytime you're looking for an angle. And then you just type in what you have, 4.37 divided by 7.25. And it tells me that that's 52.9. We're going to round all of our angles to the nearest degree. So 53 degrees. Angle A is 53 degrees. All right. So now that I know angle A is 53 and this is 90, I could just subtract from 180 and get angle B. But instead, I want to go ahead and practice with our trig one more time. So if I'm going to use my trig, these are still the only two sides that I have. But this time, this 4.37 would not be the adjacent. It would be the opposite of angle B. And the hypotenuse is still the hypotenuse. So if I use for angle B opposite over hypotenuse, I'm using the sine ratio. So sine of angle B is 4.37 over 7.25. Okay, so I'm still looking for an angle here. That means I've got to use an arc or an inverse sine. So arc sine, second sine or sine -1 of 4.37 divided by 7.25. So I get 37 degrees. And those do add up to 180. Okay. Now, on your homework, there's a section in there where they did not draw the triangles. They just tell you stuff like this. Like they're going to tell you to find all the missing parts, just like we were doing, And they might tell you that side A is 5 and side B is 7. But in all of the triangles that are in that homework section, they tell you that angle C is the right angle, okay? Angle C is the right angle. So draw yourself a triangle, a right triangle, put the letter C at the right angle, and then you can label either one of these A and B. It really will not matter, A and B. And we said a minute ago that if this is angle A, then side A is across from it, angle B, side B, angle C, side C. So then you can label the pieces that you know. That side is 5, this side is 7, and then I could work them out just like I did here. Pythagorean theorem to get side C. If I want to solve for angle A, I would use opposite and adjacent. If I want to use angle A, this would be my opposite. This is the adjacent. I don't know the hypotenuse. So opposite and adjacent would be tangent of A equals 5 over 7. And then I would do the arc tangent to find A. Arc tangent of 5 over 7. So 35.5 or 36 degrees. All right. I won't go through all of that one, but I just wanted you to see one where it wasn't drawn for you. Okay, so also in this section, we have some word problems. So let's go over a couple of word problems. In these word problems, the only thing that is going to be a little different about them is terminology. Because otherwise, we're still using the same sine, cosine, and tangent, opposite, adjacent, and hypotenuse. So in our terminology, we need to know what angles of elevation and depression mean. So if I have an angle of elevation, that means that I am, wherever I am, my line of sight is considered to be straight across from wherever I am. And if I am looking up at something, that creates an angle of elevation. If I am looking straight across and I have to look down to see something from my line of sight, so this is considered line of sight. Oops, line of sight, straight across. Line of sight, straight across. So if I have to look down from my line of sight, that creates an angle of depression. So keep those things in mind whenever you're reading these problems. All right, this one says the altimeter of a jet approaching O'Hare Airport in Chicago reads 5,900 feet as it passes directly over the Sears Tower. Okay, the altimeter is what tells the plane how high it is off the ground. So if it reads 5,900 feet directly over the Sears Tower, that's talking about right here, is 5,900 feet. All right, at the same time, the angle of depression from the plane, so that means that the person that we're talking about is in the plane, their line of sight would be straight out. And it says the angle of depression to the end of the runway. That's down here at the end of the runway. Angle of depression is looking down, so this angle is 5 degrees. It says how far is it from the base of the Sears Tower to the end of the runway? They want us to find this side over here. Okay, so other than assuming that this is my right angle, I don't know any of the angles inside the triangle, but use a little bit of your geometry from last year. We have alternate interior angles. If this is 5 degrees and this is a transversal parallel lines, this angle is also 5 degrees. Or some of you might prefer this. If this is a right angle, then this has to be a right angle, and 90 degrees minus 5 degrees would be 85 degrees. So you could find either of those angles, either use the alternate interior or subtract from 90 to get this angle. So once we know one of those angles, and we want to solve for x, then I'm going to use this 5 degrees here. Then this would become my opposite side, and this would be my adjacent side. And if I'm going to use opposite and adjacent, that is tangent. So I'm going to say tangent of 5 degrees equals opposite, 5,900, over adjacent, x. Okay, so we haven't seen one like this where the x is in the denominator, but we've worked problems like this all year long. The first thing I want to do is get rid of the fraction, so I'm going to multiply by x. Get that out of the denominator. So now I have x tangent of 5 degrees equals 5,900. So I just need to divide by tangent of 5 degrees. All right, so break out your calculator. We're going to type that in. So we have 5,900 divided by tangent of 5 degrees. 67,437.309. And that's in feet. And it didn't ask us to make any conversion, so that's it. Now the nice thing about these is usually they're just asking for one side or one piece of our triangle, so we don't have to find all the missing pieces, just the one that they are asking for. All right, let's take a look at number 2 here. At 10 a.m. on April 26th of 1998, a building 300 feet high casts a shadow of 50 feet long. So we need a building. All right, so here's my building. And it says that it's 300 feet high. And this building casts a shadow on the ground that is 50 feet long. It wants to know, what is the angle of elevation to the sun? Well, the sun is what causes this shadow. So that sun has to be shining up here somewhere to create that shadow. It hits the tip of the building, causes the shadow. So if it's talking about angle of elevation to the sun, that means from here looking up, from the ground looking up. That's the angle we want to find. So we're going to use opposite and adjacent. Opposite the angle, adjacent to the angle. Opposite and adjacent would be tangent. So tangent of this angle equals 300 divided by 50. And you can reduce that if you want, or you can just do second tan of 300 divided by 50. Remember, anytime that you are looking for the angle, you've got to use arctangent or inverse tangents. So second tan. So we get 80.5, so about 81 degrees.